For the transmission side of the hardware circuit, we would like to generate 40 kHz signal and 200 kHz signal in order to represent signal 1 and 0. Second, we need a switching function to let the MCU to choose the desired signal. Let's see the block diagram of it. We can see that we use a crystal oscillator to generate a format signal, and then it passes through two dividing circuits, and they will divide the signal to 40 kHz and 200 kHz respectively, and then they passes through the switching circuit, which is controlled by MCU input, and finally they passes through the ultrasonic transmitter. But how can we divide the circuit? We use the decade counter LS160A. We can use this counter to divide the clock signal 10 times or 2 times. Let's see the logic diagram of it. We can see that there is a 10 stage of it, and it will reload after the 10th stage. If we capture the output at pin 11, we can see that there is a one consecutive high output, so that it can divide the signal 10 times. And if we capture the output signal at pin 14, we can see that there is a 0101 consecutive output, so that it can divide the signal 2 times. By the combination of 2, we can divide the signals as we like. However, we also need to divide the signals 5 times. So we feed the output of pin 11 and pin 14 to one LAN gate. And if we 2 output is 1 and the output of LAN gate is 0, and the 0 is fitted into the counter clear input, so that it can reload the counter at stage 5, and we capture the output at pin 13, so that we can divide the signal 5 times. By the combination of this, we can divide the signal we like, so that we can generate a 40 kHz signal and 200 kHz signal. Finally, we need a switching circuit to switch the output. It consists of 2 AND gate and 1 LAN gate. We can see that if a MCU input is 1, it will enable the upper part of the upper AND gate, and if the MCU input is 0, it passes through the LAN gate, so that it will enable the lower AND gate, so that we can switch a circuit. And this is the final PCB layout. Thank you.